Hi there everyone. In this video, we're going to be looking at a new motor from Emax, the Emax RS3. Now Emax have a pretty good reputation for building decent quality motors at a real budget price point with the Eco 2. And I want to see how this new RS3 compares to the Eco 2 and to some other racing motors. We're going to take a look at the RS3 on the bench. We're going to put it on the test stand and do some throttle and flywheel testing. We're going to look at the results and we're going to see how it stacks up against the old Eco 2 and some other racing motors as well. It's a lot to cover in one video, so let's not waste any more time. Let's get right into it. All right, so let's go through the key features of this Emax RS3 on the bench. Now, starting with the bell, the motor bell is a two-piece bell design, which means that we've got a top piece of the bell that's made out of aluminium, and that's bonded down onto a steel flux ring, which holds the magnets. The bell doesn't extend all the way down over the flux ring, like you would expect with a unibell design, and that saves a bit of cost. It's a more economical way to make a motor. It's also slightly lighter, but it does run the risk that the flux ring can sometimes separate from the top part of the bell in a hard crash, particularly if the manufacturing tolerances aren't quite right. The two-piece bell design is going to be a bit lighter, and so sometimes it's preferred for motors designed specifically for racing. If we look at the windings, we can see that the Emax RS3 uses multi-strand windings for all the different KVs. So no matter which KV or which size motor you get, you're going to have multi-strand windings. And again, multi-strand windings are a more economical way to make a motor. It's easier to wind multi-strand windings with a machine, but they typically don't have quite the same performance as a single strand winding in terms of efficiency and in terms of motor heating. Multi-strand windings typically get a little bit hotter. You can see that Emax have used some glue on the windings to kind of hold everything in place. And that's what you need to do with multi-strand windings to keep them in place. With a single strand winding, because the wire is much thicker, it tends to stay in place much better. If we look at the bottom of the motor now, we can see that we have a 4mm shaft with an M2 screw that holds the motor bell in place. Sometimes with an M2 screw, I worry a little bit that it's more likely to strip out when you're trying to remove the screw to change the bell, but they've not used any strong Loctite on the RS3 on these samples that I've got, so it was pretty easy to take the screw out and remove the bell. Once you remove the bell, you can see that inside the bell there is an O-ring cushion, and that O-ring cushion is there to protect the bearings of the motor in a hard crash. So if you have a hard knock, that O-ring is going to compress, just soak up some of the impact, and hopefully that's going to help prolong the life of the bearing and keep the motor running smoother for longer. In terms of comparison to the Eco 2, the RS3 is definitely a lighter weight motor than the Eco 2. And because the flux ring is a little bit thinner, it doesn't feel quite as durable in terms of the bell design as the Eco 2. The Eco 2 is quite a kind of heavy set, durable bell design. The RS3 is focusing more on lighter weight. Now let's take a look at some performance numbers for this motor so we can see how it performs compared to the Eco 2 and to another racing motor that has single strand windings. In terms of sizes and KV, Emax have sent me the RS3 in a 2306 and a 2207 size, so the two standard sizes for 5-inch quads, and 3 KVs, 1800 kV, 2100 kV, and 2500 kV. The 1800 and 2100 kV are going to be suitable for 6S. If you're running 4S, you'll probably want to opt for the 2500 kV. All right, let's take a look at some weights now. Let's start by weighing the Eco 2 2306. So this is the previous motor, 33.1 grams. Now let's weigh the RS3 2306. Okay, that's coming in at 30.4 grams, so it's significantly lighter than the Eco 2. Now let's weigh the Eco 2 2207, which is a 36 gram motor, and the RS3 2207, that comes in at 32 grams. So in both cases, the RS3 is significantly lighter than the Eco 2, on the order of 10% or maybe even a little bit more. All right, so now it's time to look at some measured data for these motors. And we're going to start by looking at KV. And I measure KV by driving the motor full throttle at 10 volts and then dividing the RPM that I measure by 10 to get RPM per volt, which is KV. And what I found when testing all of these Emax RS3 motors is that they all tested out low in terms of KV. as in the measured kV was significantly less than the nominal or stated kV by the manufacturer. And this is important to bear in mind because it actually changes how you're going to look at these motors when comparing them to other similar types of motor. So the 1800 kV version, normally 1800 kV would be quite a powerful motor on 6S. Because these RS3s are testing out more like 1700 kV, they're going to be better for more cruising on 6S. They're not going to be super punchy, super powerful. It's worth bearing that in mind. The 2100 kV, normally you'd think that would be a kV that's way too high for 6S. Actually, the 2100 kV versions test out under 2000 kV, so they actually are quite a suitable 6S motor. The 2500 kV version, which is obviously a 4S motor, that is not as punchy and powerful as you might expect a 2500 kV. It's coming in between 2350, 2400 kV, and so that's going to be a very safe, typical kind of freestyle or cruising motor for 4S. It's not going to be particularly aggressive in terms of the power and in terms of the battery sag that you get. So worth just paying attention to this chart before you decide which kV version is right for you. The next graph we're going to look at is a thrust versus throttle setting plot. And I've added the Emax Eco 2 and the T-Motor Veloce V2 to this graph to give you some points of comparison of motors that you might be familiar with. On the x-axis, we have the throttle setting, and on the y-axis, the amount of thrust that the motor's produced on my standard 5x4.5x3 test prop. What we can see is that the 2500 kV variant produces significantly less thrust when run at 4S voltage compared to either the 1800 kV or 2100 kV variant when run at 6S voltage. So that's just something to be aware of, that the 4S version of this motor is not as powerful as either of the 6S versions. When compared to the Eco 2, there's a slightly higher kV on the RS3, and so as you would expect, the 1800 kV RS3 is a little bit more powerful than the 1700 kV Eco 2, and the 2100 kV RS3 is significantly more powerful than the Eco 2. When we compare to the T-Motor Veloce V2, we can see that the 1800 kV RS3 is very similar to the 1750 kV of the Veloce V2, and the 2100 kV RS3 is pretty similar to the 1950 kV Veloce V2. So you can see that the difference between stated kV and measured kV is having an effect here. But it's not just top-end power that's important. The efficiency of the motor is also key. On this graph, you can see the electrical power consumed by the motor on the x-axis versus the thrust on the y-axis. I'm using a standard 5x4.5x3 test prop, and what we can see is that the 2306 2100 kV motor is the least efficient motor that I tested, followed by both 2500 kV variants of the RS3. Even when run on 4S, they're less efficient than the 6S versions. If you're looking for efficiency, the 2207 or 2306 1800 kV RS3 are going to be the ones that you want to choose. And they're similarly efficient to the Veloce V2 1750 kV and the old 2207 Eco 2. If you love these kind of deeply scientific explainer videos, why not hit the like button and subscribe to the channel to make sure you're among the first to see new videos as soon as they're released. The torque that a motor's able to generate determines how fast it's able to accelerate and decelerate a prop. And that motor responsiveness is key for holding a quad stable in the air. A more responsive motor is going to give a more stable quad, particularly in prop wash. What we can see is that there are some big differences in terms of torque between different versions of the RS3. The 2500 kV versions run on 4S are not able to generate as much torque as the 6S versions of the same motor across a wide range of RPM. And I think that's a key performance difference between a 4S build with these motors and a 6S build. The 6S build is going to be more responsive. There's also a difference between the 2306 and 2207 versions of these motors. You can see that the 2207 motor is able to generate significantly more peak torque than the 2306. And that's because that larger stator volume is giving it an advantage in terms of generating torque. Drawing out some comparisons, the 2306 RS3 is a big improvement on the 2306 Eco 2 in terms of torque. The 1800 kV versions of the RS3 sit a little bit behind the Veloce V2 1750 kV, and the 2100 kV versions of the RS3 really perform exceptionally well, even compared to the 1950 kV Veloce V2. As well as looking at the torque curves, we can also measure the responsiveness of the motor by seeing how fast it's able to accelerate that 5x4.5x3 test prop. And the results in terms of responsiveness mirror what we've seen in the torque curves. with the 4S 2500 kV versions of the RS3 performing the worst, and the 6S 2100 kV versions performing the best. The Veloce V2s perform very nearly as well as the 2100 kV versions of the RS3, and the RS3 in general performs better than the Eco 2 in terms of responsiveness. So they've taken a step forward there as well. The choice of single versus multi-strand wire for a motor winding is really important when considering motor heating. Here I've taken some thermal imaging of an Emax RS3 versus a T-Motor Veloce V2. Now, these two motors have very similar performance in terms of thrust, power, and torque, but when we look at them under a thermal camera, we can see the difference between the Emax's multi-strand windings and the T-Motor's single-strand windings. The Emax RS3 gets much hotter than the T-Motor. You can see the difference is about 8 degrees or so after just a 10-second ramp to full throttle. And when considering a racing motor where you might be at full or close to full throttle for a lot of the time, that difference in motor heating will make a big difference to the performance of the motor. When the motor windings get hot, the resistance goes up, you get more losses, the efficiency of the motor goes down, and that can cause runaway heating, which eventually can cause a motor to lose power, lose efficiency, or in the worst case, smoke. So for a high performance racing motor, I wouldn't choose a motor with multi-strand windings. And so that would tend to push the RS3 more towards the kind of cruising or maybe light freestyle type segment rather than a hardcore racing motor. So that brings us to the end of the video. And as always, the question, who is the Emax RS3 the right motor for? Well, I view the Emax RS3 as a very similar motor to the Eco 2. It's a well-made, well-designed, budget motor that's going to be good for long-range cruising and light freestyle, and it's nice and efficient provided you're not putting it under very heavy load. It's not going to compete with a more premium motor designed for aggressive freestyle or racing that's going to use single-strand windings. The multi-strand windings in the RS3 really hold it back in terms of performance in those aggressive scenarios because the motor just gets too hot, it overheats too easily. If you can find the RS3 for around the same price as the Eco 2, around that kind of $16, $17 mark, then it's a great choice because it's a slight improvement over the Eco 2 in almost every way. It's got more torque, more power, and it's slightly lighter. But if you're looking for a motor that is designed for aggressive freestyle, racing, and you're going to be high in the throttle for a lot of the time, and you need a motor that's going to stay cool, then I would look past the RS3, look at a more premium motor that uses single-strand windings. I hope you enjoyed this video and that you now have all the information you need to know whether the Emax RS3 is going to be the right motor for your next build. If you like these videos and you want to support the channel and you want to support the battery testing that I'm hoping to do in the near future, then please head on over to my Patreon. You can join from just a few dollars a month and you'll get access to a special area of my Discord server and sneak peeks of the new products that I'm working on, as well as supporting purchases of new test equipment like the battery tester. If you're able to support the channel in this way, I'd really appreciate it, and there are links to my Patreon down in the video description. That's all I have for you for today, so until next time, I wish you all very, very happy flying.